Hi students, today we're going to talk about Markowitz efficient frontier. Markowitz, it's American scientist, got Nobel Prize, and also he he's in the same class like John Nash. He got his dissertation about the frontier, and uh, and then uh, he got Nobel Prize for this same dissertation. There are a few people in the world get that. John Nash, one of them, and you've seen the movie by Russell Crowe, his movie The Beautiful Mind. So the reason probably you haven't heard about Markovitz because there is no movie about him. But he's in the same class of scientists. Um, Here is his pictures. Here is about his life. He's still alive, and I'm gonna teach today this uh, his theory about the frontier. This is a fundamental analysis for portfolios. And you may ask me, Yosef, why you do fundamental, why you teach this? Because we still use it. This is a Nobel Prize paper in the 50s. The paper, he got Nobel Prize in 1990, but we still use it and we teach it. So it's a very nice, cool theory. I got it in Excel. I solved the model in Excel. And then I wanted to replicate the video that I'm showing now for different companies. The theory is simple. Markowitz create a frontier, and the frontier reflects the maximum return for a given risk. Uh, he says that if you this is a risk that you're willing to take, the maximum return you can get is this. If you want to take more risk, that's the maximum return you can get. So he mapped the risk return relationship, and the portfolio here, it's not good an efficient portfolio because for this amount of risk you can go a little bit up and have more return. But this portfolio is desirable, high return, but not attainable because there's no risk in the world you can take to get this portfolio. An attainable portfolio and efficient portfolio, and in between them, there is efficient frontier, which reflects the maximum return for a given risk. So mathematical paper, the mathematical things is it's not easy. He says in his theory that give me, suppose you have n assets. So I'm going to solve the weight for how much I'm going to invest in every asset, such as I maximize the sum of them. This is a sum of the weight multiplied by the return for a given risk. So if you are investors and you have n assets, you said, what is the maximum return I can get for a sigma risk in a portfolio like 0.06, for example? So what maximum return I can get? So that's what we do here. The W's are the weights, the Rn is return for this asset, and sigma is the portfolio risk. The way we did it in Excel file. You will have an Excel file like this, and I'm going to explain it. Maybe by now you say, Joseph, I have no idea what you were talking about it. What I understand, there's some guy, his name is Markovitz, and you showed me his picture. Okay, so now I'm going to explain it more, go back to the back and forth to understand what you're doing. Suppose you like three companies, ATT, GMC, and USX, and there is a T-bill at 5%. T-bill is a treasury bill, maybe now 3%, but let's keep it for 5. And then the question is how much you want to invest in each of these three companies and the T-bill. Well, how much to invest money, like weight, it depends. And here are the weights that you can invest in each company, such as the sum of the weight equal to 1. The weights has to do with your goals. What is the desired return and how much risk tolerance you have. Obviously, the more return you want, you have to tolerate more risk. So risk return relationship between here, and that's exactly in a draft. If you want to maximize return, you have to set how much maximum volatility I can take. So if you tell me how much volatility, I can tell you how much return maximum you can get. Now, how I got this return? It's simple. You go to Yahoo Finance. We did that many times. So Yahoo Finance has it monthly, the data. That's fine. You go apply. I went from 97 till 21 and apply and download. And you open it. And then you go to the last observation. For example, if Amazon is in your portfolio, look to December 2020. So December 2020 equal the return, and that last observation equal December 2020 minus December 19, close parenthesis, divided by 19. So that's 1. Because we do annually. This is a monthly data. You need to make it annually. So you do here, right click, okay, and copy. Right click and save values. Observation number 11 will be the following. So this is 1. This is 2. And then 10, the same. We go all the way up to 2018, December 2018. So right click. First, I have to calculate the return. This one, right click, right values. And that's a return for Amazon in the past 12 years. Or you can do 10 years. You didn't have to be 12. So you do that and you choose. So you choose your companies and you do that. Once you get the return, you do right click, copy and paste values here. So I did that already. The 3 companies, the T-bills is here. This is the weight, how much you're gonna have weight, and this is what Excel is gonna give you. Don't touch those. The sum of them equal to 1. So what this matrix? This is a covariance matrix. This is the covariance between ATT and ATT. The covariance between ATT and ATT is basically the variance. And the variance between GMC and GMC here, this is a variance, a covariance. This is diagonal, we call it, for these companies. So the covariance between GMC and ATT equal the same covariance between GMC and ATT. So ATT covariance of ATT and GMC equal the same covariance GMC and ATT. It doesn't matter if you put them how you do that. And you can see here the equation. That's the covariance. Here you can see it. And if you go here, so the covariance between, so that's a variance basically. If you go here, you can see the covariance between the blue and the red. So this is done for you. This is done for you. All what you have to do is just put the annual data for the companies of interest, Microsoft, Apple, Amazon, whatever you have, and TPL 5%. Now, the question is, he says, his model help us to give the W into WN. What we need is to tell what objectives, and the model will solve the W1 to WN. So now what we need to go here and have something called off solver. How to get off solver? You go file, options, add-ins, go, and there's a box called solver add-ins. Check this box, do OK, and then it's gonna come here in the data. In the data tab, you will see it here. Good. You go to off solver, and then you ask, what do you, as solver ask you, what do you want? You said, I'm gonna maximize the return. Here is my return. I want to maximize this return. So I'm gonna maximize, you see, I click maximize this one, the return, by changing the cells. What changing this? What cells we change? We change only the weights. Don't include the one. By changing these weights, subject to what are the conditions that the sum of the weight. Let me delete the condition and delete. The first condition you need to add is the sum of the weight is basically equal to 1. You cannot have more weights than you can this. So that's number 1. The second thing is back in here, you have to maximize this subject to this, and the sum equal 1. The second one is the variance not to exceed below or equal sigma something. So let's do the sigma here, 0.03, for example. And then you do okay. So the variance or the risk of the portfolio not to exceed 0.03. Okay, and solve and do okay. So now for this risk 0.03, the maximum return you can get is 19%. But to get 19% and 5, you need to have this kind of weight. All right, this kind of weight. Let's do a different problem. You want to maximize the return subject by changing the cells, and the sum of the weights stays the same. Now I'm going to change this. I'm going to make it like, let's assume I'm going to take more risk. 4. The question, how much maximum return I can get if I want to willing to take more risk. I do okay, I do solve, I do okay, and boom, I got 21%. So I went from 19 point something to 21.7 percent annual rate. So what weights I got here? These are the different weights that I'm gonna do in my portfolio to get up to 0.04 risk and 0.2175 return. So over here, you can see that I want to maximize the R subject to the risk. So I want to do this exercise, and at home I wanted to replicate the work. So this exercise says solve. I want to maximize the return, the sum equal to 1, and this I'm going to change it. You see here, the risk below 0.008. So the risk is below 0.008. Do okay. Solve. Okay. So what I want you to do is copy these, right click, and put values. So this is the way to solve this problem. If I want the risk below 0.06, well, I'm going to go solver. I'm going to change that, make it 0.06, solve, okay, and this what you got. No, not I did wrong here. I need to do this. Right click and save. Okay, so we solved the first two here. Okay, now we can solve this minimize return instead of maximize. You can minimize risk, subject to your return doesn't, if your goal is to have 25% return. So you can say to get to 25, how much minimum risk I need to take. So what if your goal is to be, I want to have that return, what is the risk to achieve that return? Before we said this is the maximum risk I'm going to take, how much maximum return I can get. Now I'm going to do it a different way. I want to get this return, what's the minimum risk to achieve that? And what's the allocation? So what we're going to do different solving. Solve, not maximize, minimize risk. The risk is here. By changing the cells H6 to H9, which is the weights. And my return, now this is going to be my return, desired return, not less than or equal. I want it to be above, let's say, 0.16, I see here, 0.16. And then I do okay. So I want to minimize the risk. I want to minimize the risk. And the risk is this. This reflects all the portfolio risk. For this risk, how much desired return I can get? I want to get a return above 16. Solve. Okay. So then in that case, right click and boom, I solve it. The final thing is I want to have a return of 23%. But look, if you look at the data here, the maximum return you can get here, if you put all of your money at GMC, you will get 21%. That's the maximum money you can get. But if your desired return is 23, then you're in trouble. So how to do, not in trouble, you have to, there's something going on. So how to do that? Solve, minimize the risk, change your weights, but my desired return is 23%, which is still higher than the highest, still higher than the highest return, 23. Sorry. We need to change that. So to be 23%. Okay. Solve. Okay. Boom. We get that. But how we get that? How we get what exactly we want? Well, look what we have here. We have here 24.5% in this, 70% in this company, 21% in this, and then you go short in the T-bill is negative weight in the T-bill. So basically you will sell T-bill, you get cash, and you put this cash in company called GMC. So you short T-bill, you buy cash. He did not, Markowitz did in his Nobel Prize paper in 1954 probably. He didn't have a short. He didn't allow short. I allow short. I extended the model, play with it a little bit. So I allow short because in modern finance we have short. We can do short. So what's your homework? Your homework is to choose. You choose this setup that I have here. Just to change one company. Just add different company here. Get the observation for this company. And then do the same exercise that I did here. That's all. So solve it. So do a video. Use everything here. Just to change a company. Change just one of these companies are different. Change it. And then redo the exercise I did here. I'm going to do it. Once you understand what you're doing, it's simple. So the first one, you go off solver. I want to maximize. You see black here and red. Black, RR. That means maximize. And the red, minimize VV. V is volatility or return. So the first one, solve. I want to maximize my R here. I'm going to be changing the cells, the weights. Make sure the sum of the weights not included because the sum of weights is going to be in the condition subject to equal to 1. And the volatility has to be less than equal something. And the volatility is this, portfolio risk. Less than equal, let's say 0.0, how much? 0.8. Okay, solve. Okay, you copy those. You put it here. Look at, if you want to take very little risk, most of your portfolio will be bond, by the way, T-bills, just to be careful here. And then you do one for the R volatility below 0.06, which is more volatility. So what you have to do, you take this one, you change it, and you make it here 0.6. Okay, solve. Okay, piece of cake. Right click, you do it here, you do that, and then you do the other way around. Minimize the volatility for risk for return above something. Well, now we're going to go to minimize, but the cell for portfolio volatility or portfolio risk is this. We're going to change the cell. You can don't change those. The sum of the weights is this, and then you're going to change this. We want the return to be above something, 16%, for example. 0.16. Okay, and solve. Okay, and you copy those. You put them here. And if you want to do the 23, you just change that, change it to 3. How much took me? 10 seconds to get that. and you're done. So these are the weights that you see here. You're going to go short with bond. All right, students, I'm done for today. Basically, we did Markovitz, how to optimize your portfolio. It's a modern finance theory. You get Nobel Prize. I hope you enjoyed the video. All I'm asking you, replicate the work, do this, do the same, use Excel, but change one company at least. If you want to change all the companies, good. So then, if you have a real portfolio, you're investing, then you put your company and see how much you're doing versus what actually the best optimization versus what you have. Thank you very much.